Today we're going to talk about proportional relationships, and we're actually going to spend 2 days on this. Today we're just going to focus on proportional relationships in tables. So let's go and highlight our learning targets for today. So I can create tables and graphs to represent proportional relationships, and then I can determine whether two quantities are proportional by looking at the table or the graph. Okay, so you're going to be able to make your own tables and graphs for proportional relationships, and then I'm going to give you some data, and you should be able to tell me if it is proportional based on that table or graph that you just made. Okay, all right, so we'll kind of define what proportional relationship means after we go through this first example. So Kara's having a tea party and wants to know how many cookies to buy. She checks Kroger and finds that cookies she wants come in boxes with 10 cookies in each box. Make a table to help her figure out how many cookies she's going to need to get to compared to how many boxes, or how many cookies she gets compared to how many boxes she buys. Okay, so we know that there are 10 cookies in each box. Let's just kind of think about this and fill out our table. So if she doesn't buy any boxes of cookies, like no boxes of cookies at all, she's going to have 0 cookies total. Okay, here it says that there's 10 cookies in each box. So I know that if she buys 1 box, she's going to have 10 cookies. If she buys 2 boxes, she's now got 20 cookies. 3 boxes is going to give her 30 cookies, and 4 boxes will give her 40 cookies. So really, when you're making this table here, we're just looking at the number of boxes that she buys, and then we're just multiplying it by 10 to figure out how many total cookies she'll end up having. So 1 times 10 is 10. 2 times 10, 3 times 10, and 4 times 10 gives us those number of cookies that she would end up having. Okay, so here they're asking me, is this a proportional relationship? And similar to how we did unit rates, or how we talked about unit rates last class period, this is a proportional relationship because there are equal ratios, or fractions. A ratio is just a fancy way of saying fractions. Equal ratios between y and x. And just like when we looked at unit rates in tables and unit rates in graphs, we always did y divided by x. Same thing here. If you do, remember in tables, this first column is the x column, the second column is the y column. So if you do 10 divided by 1, you get 10. So I'm doing the y divided by the x. And then if you keep doing this, if you do 20 divided by 2, 30 divided by 3, 40 divided by 4, if you divide those, if you take the y value and divide by the x value, just like we did with unit rates, you're going to get 10 every single time, or 10 over 1, and we'll talk about what that would be as a unit rate. Okay, so I know it's proportional because there's 2 ways to figure that out. With a table, you just want to make sure that when you take y divided by x, you should get the exact same number, which here we got 10 every time we did that. Also, if your table has 0, 0 in it, that's a good indicator that it's going to be a proportional relationship as well. Okay, so you don't have to do the dividing with the zeros, but for everything else, divide it and see if it gets you a proportional relation, or if it gets you the same number. Okay. All right, and then from here it's asking how much, or how would we figure out how many cookies would be in 5 boxes. And so we can write this as a unit rate and then figure it out. So we know that there are 10 cookies in 1 box. So if we're trying to figure out how many cookies there are in 5 boxes, then I want this bottom number to be a 5 instead of a 1. If I'm trying to move from 1 to 5, I'm going to multiply by 5 and do the same thing at the top. So if I do 10 times 5, I know I'll get 50 cookies. Okay, so that tells me that there would be 50 cookies if I bought 5 boxes of cookies. Okay, so I'd have 50 total cookies. And I know there are shortcuts. So if you're like, okay, well, I know that there are 10 cookies in 1 box, so however many boxes I have, I'm just going to multiply that by 10. That's fine. So here I have 10 boxes of cookies, and each box has 10 cookies in it. That would give me 100 total cookies. All right, go and try this. Try the next one. What if you bought 30 boxes of cookies, or 30 boxes of cookies, how many total cookies would you have there? All right, so if there's 10 cookies per box and you bought 30 boxes, that would give us 300 cookies. Okay, so we are going to graph this one just to see what the graph looks like. And we'll talk a little bit about graphs today, but we'll mostly just focus on our tables. So if you look at your data here, you have the point 0, 0, and notice your graph is already labeled. The x-axis is boxes of cookies, which we said in our table. Number of cookies was the x, and then the y-axis is total cookies, and that's what we have there. So total cookies, that's your y, and then number of boxes of cookies, that's your x. Okay, so let's graph these ordered pairs. When we graph them, 0, 0 is here. 110, 220, 330, and 440. So there's my graph. And since we already learned in the table that it's proportional, then it means in the graph this is also going to be proportional. We'll take a look at what we notice about this graph. So yes, it is proportional. And if you look at the graph, let's take a look at a couple things. One thing I want you guys to notice is in the graph right here, the graph goes through the origin, so through 0, 0. Okay, so I know it's proportional because it crosses the origin. So I'll say yes. Crosses the origin, and the origin is just 0, 0. Okay, and one more thing I think we could notice about this graph, it crosses 0, 0 right here, and then also if you were to connect these dots, they would make a straight line. Okay, so it crossed the origin and made a straight line. Okay, and we've talked a little bit about graphs that have to make a straight line. If it has a constant rate of change, it would have to make a straight line. The rate of change here in this table and in this graph, it is a constant rate of change. So that also makes a straight line. But our graph right here, it crossed the origin and it made a straight line. So I know that it is a proportional relationship. So with a graph, there are two things that have to happen. They have to cross the origin and they have to make a straight line. If those two things happen, then it's a proportional relationship. Okay, next thing it's saying is, can you extend the graph beyond the points from the table? So right now, the table only has us buying 5 boxes of cookies, but ask yourself, could she buy more than 5 boxes of cookies? Well, she could. She can buy as many boxes as she can afford. So here, yes, we can extend this beyond. Let's go ahead and do that. Give me a straight line, extending all the way beyond the graph with an arrow through it. So that just shows that she can buy more than just this graph has her like at 8 is where it falls off the graph. She can buy more than 8 boxes of cookies, or she can have a total of more than 80 cookies. She would just have to buy more boxes. Okay, so can you extend the graph beyond the points in the table? Yes, you can. That just means she's buying more boxes of cookies. Okay, and then use your graph to figure out how many cookies are in 8 boxes. So if you look at your graph, boxes of cookies are on the bottom, so find the 8, follow it up, follow it over. Okay, so as an ordered pair, this would be 8, 80, because you're going over 8 and up 80. Okay, so we'll write this with the problem over here. So you're going over 8 and up 80, and notice this x value, the x's are the boxes of cookies, and this number is the total number of cookies. Okay, so what this ordered pair tells us is that when we buy 8 boxes of cookies, this is how many total cookies we will have. So using that ordered pair, go ahead and tell me, if she buys 8 boxes of cookies, how many total cookies will she have? All right, so if she buys 8 boxes of cookies, we know that she will have 80 cookies total. Okay, and you can use your graph, or remember above here with the table, we just multiplied to get our total number of cookies. Multiply the boxes by 10. All right, I do want you to take a second to fill out some of these vocab words. So in this vocab box right here, proportional, they're quantities that have the same relationship. I'm going to make a note over here and say if it's a table, then you're going to do y divided by x, and you should get the same ratio every time. Okay, so if it's a table and you want to tell me if it's proportional, then all you do is you take y divided by x and see if you get the same ratio. Okay, and then if it's a graph, like we just saw up above, two things have to happen. It has to cross the origin. So I'll just say goes through origin and makes a straight line. All right, so it's got to go through the origin and it's got to make a straight line in order for it to be proportional on a graph. So those two things have to happen for a graph to be proportional. It's got to go through the origin, it has to go through 0, 0, and it's got to make a straight line. It cannot make a curved line at all. Okay, so proportional just means that the quantities have the same relationship. So in our examples right here with the cookies, the relationship is that we're taking the cookies, we're multiplying by 10. Take the boxes of cookies, multiply by 10. Take the box of cookies, you're just taking however many boxes of cookies they bought and you're multiplying it by 10 to get the total number of cookies in the box. Okay, so it's the same relationship. You're doing the same thing to get from the x value to the y value. You're multiplying by 10. Okay, and then constant of proportionality, we'll talk a lot about this on our 8C day, but our constant of proportionality is just the number that you multiply or divide by. So in our cookie example, we're multiplying the boxes of cookie by 10, so then 10 is called our constant of proportionality, or sometimes they use k equals, and they'll say k equals 10. So for example, for this one, we would say k equals 10, because all you do is you take 1 times 10 to get 10. 2 times 10 to get 20. You're multiplying all those x values by 10 in order to get the y value. So your k value is a 10. Okay, and then again, unit rate we spent a whole day on. This is a rate that has a denominator of 1. And so for this example right here, our k value is the same as our unit rate. It would just have more labels. Okay, so the unit rate would be 10 over 1, which means you get 10 cookies over 1 box. That would be your unit rate. Okay, so notice here your k value and your unit rate are exactly, and I'll write unit rate next to this so we know what it is. So this is our unit rate. Your k value and your unit rate are going to be exactly the same. It's just your k value, you can just write the number, and then your unit rate, like we talked about when we talked about unit rates in class, is you have to write it with all the labels. You have to make sure you have all the labels with it. All right, so your k value would be 10. Your unit rate is the same. It just has more labels. 10 cookies over 1 box. It just has more context to it. All right, so there's your unit rate. So again, your constant of proportionality, if it's proportional, these two things would be exactly the same. It's just this one is a number and this one has labels with it. So it's a number over 1 and it's going to have some labels. All right, so make sure you have that table filled in for all of your vocab, and then relate each vocab word to the cookie example. So this is where we can say on your table, we'll skip down to constant of proportionality even though I just wrote it up there. So your constant of proportionality is 10. Because you multiply just the number of boxes, multiply it by 10 to get the total number of cookies. And then we just said it's 10 cookies over 1 box. Okay, and to get that, we would do 10 divided by 1 gives us 10. We also did 20 divided by 2 in our table. Also give us 10. So I'm just rewriting this that we did. We did 10 divided by 1, 20 divided by 2, 30 divided by 3, and 40 divided by 4 are the other things we did. Okay, so we also did 30 and 3 and 40 and 4. Okay, so we wrote them as ratios. Ratios just means fractions. We wrote them as fractions. We divided those fractions. When we did that, we got the exact same number every single time. Okay, the number we got is our constant of proportionality, so that's this part. And then it's also our unit rate. It just has more labels with it. All right, let's try one more example. And in this last example, notice here I'm telling you what the x is and what the y is. Sometimes it's harder to see that when you have tables that are horizontal instead of vertical, but the y values are down here at the bottom. The x values are up here at the top. So notice in your title, you're talking about the distance that's traveled by a train. First thing I want you to do is just set up your ratios. So compare the distance traveled to time. So they want you to compare distance to time, meaning put distance on top, the miles on top, time on bottom, so minutes on the bottom. So I'll help you set up the first one, and again, you're always doing y divided by x. So every single time when you're looking at a table, y divided by x. Okay, just like they wrote right here, you're doing y divided by x. So distance over time. Your first distance that you see is 30. The time that goes with it is a 10. So we got 30 over 10. We have 60 and 20. We have 90 and 30. And then we have 120 and 40. Okay, so all I did is I just took the table and this first set of data I put here, but remember it's y divided by x, then take this, y divided by x, do this, y divided by x, then lastly you have this, y divided by x. Okay, so go ahead and for this one, go ahead and figure out what do you get for your ratios. When you divide them, and you don't have to keep it as a fraction. If you get a whole number, you can just keep it as a whole number, but when you divide, when you do the y value divided by the x value for all of these, what do you get? All right, so when you do your dividing, 30 divided by 10 will give you 3. This should give you 3. That'll give you 3. And that'll give you 3. Okay, so every single time here, the ratios that we get when we are dividing, when we're figuring out if this is proportional, these ratios are the same. Okay, and again, your key thing is you have to make sure with your ratios, you're doing the y value divided by the x value. So the y is on top, x is on bottom. Okay, so then it's asking, is this a proportional relationship? Yes, we know it's a proportional relationship because of this, because of these 3's. I got a 3 every single time. So yes, it's proportional because I have equal ratios. I'll put equal y over x ratios. Okay, so because all of these fractions simplified to the same number when I divided them, I know that that is proportional. Okay, my constant of proportionality is just the number you got when you divided everything. So here when I divided y divided by x, I got 3. So that means my k value is 3. Okay, and that's my ratio from above. And then lastly, they're asking for the unit rate, so how far the train would travel in 1 minute. Well, what we said here is that your k value and your unit rate are the same. It's just your unit rate has labels with it, and your k value doesn't. Okay, so for this one, my unit rate is the same as my k value. I'm going to write it as a fraction, and I'm going to label it. So go ahead and tell me, what is the unit rate in this example? What do you think with labels? All right, so my unit rate here, my k value is 3, so my constant of proportionality is 3. So I'm going to write that as 3 over 1, and then we have to label it. And remember, your y is on top, your x is on the bottom, the y is distance in miles, and then the x is time in minutes. So it's 3 miles over 1 minute. Okay, so my final unit rate, 3 miles, 1 minute. Awesome. Okay, last thing we're going to look at here is if you go to the very last page of your notes, you have some tables here. And here in our tables, we have some missing pieces, and I need you to fill in the missing stuff on your tables. Okay, so the tables below, I'm telling you that they are proportional relationships. I just need you to fill in these missing values. To figure out these missing values, there's a couple ways you can do it. You can find the constant of proportionality by taking y divided by x. Remember, your constant of proportionality is just going to be y over x. It's what you get when you take y divided by x. So you can just do y divided by x. Okay, so in this example, I can't really use anything here because I'm missing a spot, this one. I'm missing this spot and I'm missing that spot. So the only numbers I can use are the 2 and the 6. So I'm going to do, if you do y divided by x, it'll tell you what your constant of proportionality is, and then you can use that to figure out all these missing numbers. I know that if I take 2 divided by 6, and then it's going to give me a repeating decimal, but your Desmos calculator can give you that as a fraction. So if I do 2 divided by 6, push the fraction button, I get 1/3. Okay, so what that means is that just means I can take my x value, multiply it by 1/3, and I'll get my y value. So next to x, let's say multiply by 1/3. And something you might notice here is instead of multiplying by 1/3, we can take a look at the 6 and the 2 and see what else we can do. Okay, but again, all this means is it means when you look at your x value, you should be able to take your x value, multiply it by 1/3, and it'll tell you what your y value is. So for example, if my x value is 15, I'm going to do 15 times 1/3. And I'm also going to do 9 times 1/3, and that will give me those two missing values right there. Okay, the first missing value is going to take a minute to do, but these ones, I can take 15 times 1/3 and then 9 times 1/3 to get those answers. So 15 times 1/3 gives me that, and then 9 times 1/3 gives me that. So I got a 5 and I got a 3. Okay, so this missing value is 5. This one's got to be 3. Something else you might notice, because the multiplying by 1/3 could be a little bit confusing, something else you might notice, and I'll show this in blue, is if you're trying to get from 6 to 2, you do multiply by 1/3. So 6 times 1/3 should give us 2, which it does. But instead of saying multiplying by 1/3, try to think dividing. So 6 divided by what is going to give me 2? Well, I know if I take 6 divided by 3, that's going to give me a 2. Okay, so then to find this missing number right here, I can just think backwards. So if I go from x to y, I have to divide by 3. Then going y to x, I'm going to multiply by 3. Or what you could say is you could say, okay, what number can I divide by 3 and it'll give me 4? So just think about that for a second. What number, think of a number, what number can you divide by 3 and it'll give you 4? What do you think? All right, so if you have to think of a number that you can divide by 3 to give you 4, I know 12 divided by 3 is going to give me 4. Or again, if you don't want to think it as dividing by, you could also think of it as multiply by 1/3. So think 12 times 1/3 should give me 4. Let's check to see if that's right. 12 times 1/3, and there it is, you get 4. Okay, something else you can do is if I give you the y value, just do the opposite of dividing by 3. So we know to get from x to y, we divide by 3. So then if you're trying to go from y to x, instead, if you're trying to go backwards, do the opposite of dividing by 3. Well, the opposite of dividing by 3 is multiplying by 3. So when you take 4 times 3, that also gives you 12. All right, let's try another one. So let's take a look at number 2. And again, I'm going to figure these out by finding the constant of proportionality. So I'm going to take the only data values that I have 2 of. Here it's the 3 and the 18. I can't use any of the other numbers because they're all missing something. So I'm going to write this as 18 over 3. So I know my constant of proportionality is 6. So all that means is I'm just taking this x number and I'm multiplying by 6. Okay, so I can take 3 to get from 3 to 18. I multiply by 6. Okay, which means that to get this number, I'm going to multiply by 6, and then to get from here to here, I'm also going to multiply by 6. All right, so let's try that. Let's try to find your missing value. Go and find this first missing value. If the x is 4, what is the y value going to be? Okay, so if the x is 4, I know that 4 times 6 is going to give me 24, so my y value is going to be 24. Okay, let's try this other one. If the x is 7, what's my y value going to be? I know that 7 times 6 is 42, so I know that my y value is going to be 42. Okay, and then lastly, you're going backwards. So instead of going from x to y, I don't give you the x here, I give you the y. So go backwards, and this you can just say, okay, the opposite of multiplying by 6 would be to divide by 6. So let's try that. If you take 54 divided by 6, what would you get? Okay, and I know that when I take 54 and divide it by 6, I should get 9. Or if you just want to think what number, what number can I multiply by 6, that'll give me 54, and you'll get 9 that way as well. All right, if you want to try this last table, you can. I'm going to skip down to these ones where we have to use just kind of the directions to fill in the table. For example, 4, they say make a table to model the total cost of brownies if each brownie is 75 cents. Okay, so they tell you the number of brownies that you're buying. I want you to tell me how much money it's going to cost you. Okay, we know each brownie. This 75 cents here, that's your K value. That's your constant of proportionality. Oh, 72, 75. So that's your constant of proportionality. So that just means you take your X value, you multiply it by that constant of proportionality, and it'll give you that Y value. So take your X, multiply it by 75 cents, and you will now get your Y value. You'll get your total cost that you would spend. Okay? All right, so we just got to type all these in. So you got 75 cents times 2 gives you $1.50. 75 cents times 7, $5.25. And then go and tell me, what do you get for this last value? What would your total cost be if you buy 12 brownies? All right, so if you buy 12 brownies, we're just going to make this a 12, and we end up spending $9. Okay, so that's all we got to do. Make sure you read your directions. In your directions, it'll tell you what to multiply it by. It'll tell you your constant of proportionality, so you just multiply by that. Last one we're going to do together, make a table to model the total amount of time it takes to run the distance in the table if each mile takes 8 minutes. So this 8 minutes right here, that's your constant of proportionality, which means you're just taking however many miles you run, and you're multiplying it by 8 because your constant of proportionality is 8. All right, so go ahead and fill out your table for this one. Okay, so if you run 5.1 miles, which is a 5K, if you run 5.1 miles and each mile you run an 8-minute pace, that's 40.8. So that means it takes you 40.8 minutes to run a 5K. Okay, now 13.1, that's a half marathon. If you run a half marathon at 8-minute pace, 13.1 times 8, 104.8 minutes. Okay, and then lastly, if you run a full marathon, that's 26.2 at 8-minute pace, 209.6. All right, so that tells you how long you'll be running. If you run at 8-minute pace, if you do that same pace, 8 minutes per mile, for a 5K, for a half marathon, and for a full marathon, this tells you how many minutes you will end up running. All right, so we'll finish up the rest of these notes next time I see you. Today we spent a lot of time going over tables, finding missing values from tables. Feel free to refer back to these examples because you'll have some of them on your homework, so make sure you look back at these if you're stuck on any of them. And we will spend more time going over some graphs and just talking about the relationship between graphs and tables next time I see you. But overall, we just did a lot of tables and talked about in a table, how do I know if it is a proportional relationship? So feel free to watch the video. If you have any questions, make sure you shoot me a Canvas message and I can help you out.